Hello everyone, this is a 3.2 measures of variation. So what is a variation? In the textbook, it's highlighted here, right? A way to describe how much the data varies. Yeah. Or we can say that dispersion means how far, how much the data set spread out. Yeah. Okay, so let's take a look this picture. Can you distinguish two different picture? This one is less variability, less variation, less dispersion, less spread out, right? Everything is the same word. And then last word, they said more consistent. Let's talk about this one later. And this one we have more, right? So since this is less, looking at the data set, we can see that more spread out, right? More spread out, more dispersion, more variation, more variability. Yeah. And then they say that less consistent. So let's talk about this one later. Okay. Make sense? What we are doing this section? Yeah, we have objective here. Okay, so the first one for measuring of variation, we have a range. Let's take a look. So range, what is a range? Range is the difference between the largest data value and smallest data value. So mathematically, we can say that as a formula, right? Range equal to max minus minimum, right? Okay. They say that interpretation, generally, a large range can indicate more variation. A smaller range can indicate less variation. Means that less variation, the data set is less spread out, right? Okay. Okay, so we have an example here, table 8. So student exam scores, morning class and evening class. So each one has 5 students' scores, right? Okay. We want to know about mean and median and make a dot plot for each graph. And then they ask us, are the measures of a center enough to describe the two groups? And then we want to calculate the range, right? And then what does the range tell you about morning and evening classes, right? Okay, so we know how to find the mean, median, right? So I'm gonna just bring the answer here with a dot plot, all right? Okay, so I brought the answer of mean of morning students score and then evening and also median of morning and evening students score and then dot plot here. Yeah. Okay. So everything is the same, right? So their mean is the same, the median is the same, right? Okay, I indicate M here means morning, and I indicated E means evening, all right? Okay, now we cannot really tell, right? What's going on because there Mean is the same. Also, the median is the same, right? Okay, now let's find the range. Range is, how about here? Range. So maximum minus minimum. So in that case, which one is max? 95, minimum 70. Can you please calculate? It's 25. Good. How about this? So evening. So range equal to evening 92 minus 72, which is 20. Okay, what is it telling us? We have 25 as a range, 20 as a range for evening, right? So this is the morning, and this is the evening. Yeah, so they give us also a tip that the larger range can indicate more variation, right? So since this is larger than this, so this one has more variation, more variation. And 20, we can say the less variation. Yeah. So less variation means the data set is less spread out. So this one less spread out than that, right? We can see that like a visually, right? So this one is more spread out. So let me write down. Means less spread out. Okay, so less spread out means we can say that more consistent. The data set is more consistent. Score is more consistent, right? Means more consistent. Okay, so in the beginning, I said that, oh, let's talk about this later, right? So more consistent. So that is that. So more consistent, less spread out, less variation, less dispersion, less variability. Yeah. Then opposite, more spread out, more dispersion, more variation, more variability, and less consistent. Yeah. So let's remember only one thing, then everything is opposite, other one. Yeah. Okay. So that's it, right? Make sense? Yeah. So less variation means less spread out. Less spread out means their data set is close together, right? Okay. Let me write down too. Okay. So we have a second questions example. Once again, I'm gonna bring here mean, median, range. No, mean, median, and then range. We're gonna find four, and then I'm gonna bring here dot plot. All right. Okay. Um, let's find the dot plot first. I'm sorry, the range first. So range for group number one, range for group number two. Can you please try? So we have a maximum minus minimum. That will be 10 minus 0, which is 10, right? Range for group number 2. 10 minus 0, which is also 10, right? Okay. Let me bring the mean, median, and the dot plot. Okay, so we have group number 1 has a mean equal to 5, median is 5, range equal to 10. We got the range earlier, right? Group number 2 has mean is 5, median is 5, also range is 10, right? They are identically same everything, right? But then let's take a look this dot plot. Yeah. Since range is telling us how much data set spread out, right? But then more range, bigger range say that more spread out, small range say that less spread out, right? Then less spread out, we can say that more consistent, right? About the data, about the score in the case. Okay, then since range is the same, 10, 10, right? Are they has the same spread out? Let's take a look, right? Yeah, it is. It is same spread out, right? But then looking at the individual data set there, this is the data set. We can say that widely spread out, right? And this is also mean, right? Those data set, but in that case, they gathering in the center, right? Yeah. So we can say that range is now good for check that the spread out, especially from the mean. Yeah. Okay. Then, we want to know about the exact data set, how much spread out, right? Then, okay, let's check that. Maybe we can check the average distance from the mean because the range by the formula say that largest data set minus smallest data set, right? So they care about only the largest one and smallest one, right? Okay, so let's do that. Other stuff. Other stuff will be the standard deviation, that is average distance from the mean. We want to know about that. Okay? Okay. So before we get into standard deviation, let's understand what is the deviation from the mean, right? So we have a deviation from the mean. It's the difference between a observation and the mean of data set. Okay. So if we express mathematically, that's x minus mu or x minus x bar. There is a deviation from the mean, right? Okay, let's calculate here. Um, so they have a mean, which is a 5, 5, 5, 5, 5, right? And then we will use 1 minus 5 in that case. So we have 2 minus, oh, different color. So 2 minus 5. Please calculate 5. Okay, negative 3, right? So 5 minus 5, which is 0, a minus 5 equal to 3, and 9 minus 5, which is 2, 10 minus 5, which is 5, and also 10 minus 5 equal to 5, right? Yeah, there is no space. Oops, you cannot see. All right. Okay, so we say that difference, that would be deviation, right? Deviation. All right. Since we talked about earlier, the average distance between the mean and the data set, right? Okay, how do you find the average, right? So we add everything up, divide by number of observation, right? So let me write down everything. So I will write down, we add everything up and divide by how many data set? 9, right? So we add everything up, divide by 9, what do you get, right? Can you calculate? Okay, someone got this one? All right, so what did you have? I'm missing, huh? Hold on 1 second. I made a mistake there, right? Who did not? You guys did not talk to me, yeah? So 9 minus 5 equal to 2. I think I saw the 7, right? So that is good thing I catch up right now. So there will be 4. So 4. Yeah. Okay. Now, 2, 5, negative 5, 2, positive 5, negative 4, positive 4, negative 3, positive 3, which is 0, right? So 0 over 9, which is 0. Yeah. That would be 0. Yeah. Okay. Then we say that, oh, we want to know about the average distance from the mean and the data set will be standard deviation, right? But then we get the 0, and this is not working, right? Then how do you do? How about let's make a square them? Yeah. Okay, let me bring here the definition. Okay, so we want to square them. So basically, x minus mu, we have that earlier, and then we square them. Yeah, we square them. All right, so let's do that here. I want to make x minus mu squared. So that will be negative 5 squared, negative 5 squared, which is 25. Then negative 4 squared, which is 16. Negative 3 squared, which is 9. 0 squared, which is 0. 3 squared, which is 9. 4 squared, which is 16. 5 squared, which is 25. 5 squared, which is 25 as well, right? Okay, we made them addition. So same as earlier, right? We want to take the average distance from the mean in the data set. So let's adding everything up, divide by 9. All right. So second part is average distance, right? So let me just make it shorter. So we have a 25 plus 16 plus 9 plus 0 plus 9 plus 16 plus 25 plus 25 divided by 9. Can you please calculate? So there will be 150 over 9. Good job. Which is a 16 over 16.6667. Yeah, very good. Okay, then let's talk about the unit. So since we squaring them, x minus mu squared, if we are using sample, then x minus x bar quantity squared, right? Then if we have a squared, then that square unit, right? But then group 1 has just a score point. Group 2 has just a score point, not the squared, right? So how do you make a unit not squared unit? Very good. Square root to them to make not squared unit, right? So we will use 150 over 9, which is the square root of 16.6667. Then we will get 4.08, which is 4 point round up. So 0.8, 8 is greater than 5. We do round up, so we get 4.1, right? Okay, so this is the formula what I just taught. We just showed, right, earlier. So we have population standard deviation. Now we are using this notation, right? We call the sigma lowercase. So I think I introduced to you when I talked about the sigma uppercase of in Greek letter, right? So this is a lowercase of sigma. Okay, how do you get the sigma? Then we went over, right? So x minus mu squared, quantity squared, that means the average distance, distance of deviation, right? Then we want to take the average, right? The average, how do you get the average? We make a summation of that divided by the number of observation, number of data set, right? Then uh, by unit, right? So we want just a flat unit, not the squared, right? Just a unit. Then we make a square root them to get the just a unit by itself, right? Okay, so that is the one, right? Okay, now that is what we call the standard deviation. Oops. All right, then we have a variance, sorry, not the variation, yeah, variance, yeah, so variance. So we want to know about the population variance. How do you know? So we make a square down, then from the population standard deviation, we square them. Then if we square them, then there is no, let me write down. So square them. So we have a square root of summation of x minus mu squared over n, right? So we square them. Then we don't have a square root there, right? That's how they got it here. Make sense? So this formula, so basically come from that definition, right? What is the definition of standard deviation? So average distance, each data set from the mean, right? Yeah, that is the one. Okay, now earlier, mean of population, mean of sample, we had the same formula, right? How about sample variance, sample standard deviation, right? So let me bring here. Okay, so sample variance, sample standard deviation is exactly same as population variance. and population standard deviation. But what's the difference between population and sample? We have n minus 1 in the denominator, and also n minus 1 has the name, which is degree of freedom. Okay, so why we are using n minus 1 in that case? Because why we are doing sample? We want to estimate the population parameter, right? So why we are doing statistic? We want to estimate the population parameter, right? So basically, we have a sample mean. We want to estimate population mean, right? Now we have a standard deviation for a sample. Why we want to do? We want to estimate population standard deviation and population variance, right? Okay, then in that case, we are using n minus 1. So that is, we can estimate more closely the population variance, population standard deviation. And also, we don't want underestimate or overestimate about variance and then standard deviation, right? Okay, so in that case, we have unbiased estimator, unbiased estimator. Let me write down here. Okay, so I wrote down here n minus 1. So n minus 1, the name is degree of freedom. So why we are using n minus 1? So they say that n minus 1 is unbiased estimator. So what this means? This means expected value of the sample variance equal to true population variance. So we want to make the same value with population variance, population standard deviation, right? That's why we are using n minus 1. Then why we don't use n minus 2? So n minus 2 is too big, so we can have overestimate because the denominator is smaller. Then what about the n plus 1? N plus 1 is big, so when denominator is big, then the whole thing is small, too small, so it might be underestimate. Make sense? Okay. Now, let's talk about the standard deviation one more time. Okay, so I bring in here the standard deviation. So what does the standard deviation is telling us, right? So um, standard deviation gives us idea of how close the data are to the mean or how spread out the data. And then we talked earlier, larger standard deviation means the data set widely spread out, dispersed, so more consistent, right? And then small standard deviation, less dispersed and less variation, and more consistent, right? More consistent. So let me write down. More consistent. So more consistent is better, right? Yeah. Okay, so here you go. We have a picture, right? So small standard deviation, this one, large standard deviation, this one. More consistent, more consistent. Okay, now I'm gonna show you how to find, how about sample? Sample is better because population is a lot of data set, right? Yeah, let's do sample, yeah? So I'm gonna show you how to find sample variance, sample standard deviation by hand. And then I'm gonna show you how to find population standard deviation, population standard deviation, population variance, and sample variance, sample standard deviation by using StatCrunch. Yeah, okay. Okay, so I brought the example here. So we have a tiny data set, only 3 data set, because I can show you by hand. So sample standard deviation and variation, right? So either way, we can show that we can find standard deviation first or variation first. We can do the either way. Then we can just follow the formula, right? Okay, what do you want to find first? Standard deviation first, okay. So let's do that then. Let's follow this one. Yeah. Okay, so we have 526, 36, right? So let me draw the table first. Okay, so I made a table. So x of 1 equal to 5, x of 2 equal to 26, x of 3 equal to 36. And then I found the mean here. So by the tip, right? So if we have original data set is a whole number, we can round 1 decimal place. Yeah. If original data set is 1 decimal place, then we can make 2 decimal places for that, right? Okay, so that will be x of 1. So x of 1 minus x bar, which is 5 minus 22.3. Can you please calculate? It's a negative 17.3, right? How about this? 26 minus 22.3. It's a 3.7. How about 36 minus 22.3? It's a 13.7. Okay, let's make a square down. So we have a negative 17.3 squared. What do you get? So 300.33. And we have a 3.7 squared, 13.47. We have a 13.7 squared down. We have a 186.87, right? Okay, we finished that. Now we want to make a sum. So can you add them everything up here? All right, so we get 500.67. We finished, right? So let's do that here. So we have a square root of summation, which is a 500.67 over how many n? 3, right? So 3 minus 1. So inside the square root, right? We have to be careful. Inside the square root. Okay, now what do you get? So it's a 15.82 unit. It's a minutes, right? Yeah. So we talked about the unit earlier, not the minute square, right? Minute. That's why we have to take the square root. All right, very good. Now, yeah, crazy. I will show you how to use StatCrunch. All right. Okay, so I'm gonna show you how to use StatCrunch for group number 1, group number 2, quiz score from 9 students. So this data set is not much, so I'm gonna just type So by stackrun, we have a 15.71, right? And then by hand, we have a 82. It's slightly different. Okay. Let's find out variance. So if we have a standard deviation, right? So variance will be, let's make the first letter V, and then S squared, which is 15.82 squared. Let's calculate. Yeah, I totally forgot. If we have a whole number, then we can answer the decimal place, one decimal places, right? So I made a 15.8. And then if we make a square them, that will be 249.6. It's a slightly different with the second. Okay. Oops, I cannot move on. All right. So we know how to use a stack range. Very good. Okay. So now let's talk about the empirical rule for bell-shaped data. Okay, what is this? So we have a rule. Name is empirical. Okay, so empirical rule. When do we use? We want to use it for the bell shape. So bell shape looks like that, right? If we want to know about percentage, if we want to know about the number in the case, then we want to use that, right? Okay, so let's talk about the percentage first. So they say that 68% within one standard deviation. So this is from the mean, right? What is the standard deviation? That is average distance from each data set from the mean, right? So from the mean, so this is the mean, right? Then we say that this much will be one standard deviation from the mean, all right? And then this one will be two standard deviation from the mean, right? And this is a three standard deviation from the mean, okay? All right, then they give us 68%, right? So if we have a 68%, we have a two part, what do you get? So each segment is 34%, right? So each one has a 34% here, 34% here, right? Okay, now if we have a 95% within two standard deviation, so this part is 95% within two standard deviation, right? Okay, so we were using 68% inside, right? So 95% minus 68%, so we got the 27%, right? So let me see, 95%, let me do this one first. 68% we will divide by 2, then 34%. That's how we get that, right? So number one. Number two, we have a 95%. So take away 68% from there, right? So there's 27%, right? So we will get 27%, that segment, right? But then we have to divide, right? 27% divided by 2, which is so 13.5%, right? So there will be 13.5%, 13.5%. Yeah, that segment. Yes? Okay, now if we have 99.7%, but 95% occupied inside, right? So number three, so 99.7%, but inside has 95%. What do you get? So we get 4.7%. So we do divide by 2. What do you have? 2.3%, right? 2.35%, sorry. So that would be 2.35%, 2.35%. So that's the number 3. That's how we get it, right? The each segment percentage. Okay. Any question? All right, then let's do example here. So example we have, we calculated the 2 standard deviation above and below the mean age of US president at inauguration. Interpret result in terms of empirical. Okay, so let's find out because we did not find out, right? So 2 standard deviation above and below the mean. Yeah, so that is 2 standard deviation here, right? Okay, let me use that information from here, right? So let me get that. So this is the one. Okay. All right. So 2 standard deviation means mu, there will be 2 standard deviation, mu plus 2 times of sigma, mu minus 2 times of sigma, right? So mu plus 2 times of sigma, mu in the case of 55.5. If we have a original one is a whole number, then we answer 1 decimal places, right? Okay. Then plus 2 times of sigma. Sigma is a standard deviation. This one. And this is mean, right? So 7.25. So 7.3 then. Yeah, 7.3. Because we do round up, right? Okay. Now, can you please calculate? So we get 70.1. Good. How about the subtraction part, right? So same number, subtract. So if you want to use a calculator, you have to have parentheses in your calculator, right? Otherwise, they subtract first, all right? So what do you get? It's a 40.9. Very good. Okay, how we interpret 2 standard deviation in the case, right? So let's say that this is approximately 70, and then this is approximately 41, right? So we talk about the age, the president's age, right? So 95% of ages should be within 2 standard deviation of the mean. That is 41 and 70. Yeah, so let me write down. Okay, so I wrote down here 95%, oops, 95% of ages should be within 2 standard deviation. Oh my gosh. Um, So standard deviation SD of the mean, which is 41 and 70, right? So there will be 41 and 70, right? In other words, we can take a look, confirm. Let's see. Can you check that? How many numbers the age is over 70? So 70, 78. Yeah, two numbers. So 70 is not included there then, right? Okay. Then how about between 40? Yeah, we get, hold on one second. Let me bring the histogram. It's easy to look, right? So if we calculate, if we count how many, how many, so how many the data set between um what they say 41 to 40, sorry, 40 and 70, right? So if we calculate, there is 44 out of 46, yeah? Because we can see that only 70 and 78 out of the 41 and 70, right? So 44 out of 46, yeah? So if we calculate, what do you get? 44 out of 46, that will be 0.9565, which is we times 100%, then move to the decimal point to the right twice, so 95.65%, which is 95.7%, which is very similar with empirical rule, right? Yeah. So when do we use? If we have a bell shape, then if we want to know about the percentage, or if we want to know about the variable, yeah, in that case, the age of the president, right? Yeah. All right. Okay. If we don't have a bell shape, then we are using Chebyshev's inequality. So let me bring here, what is Chebyshev's? Okay, so I wrote down Chebyshev's theorem. This is from the textbook. So it's a simplified version for any data set or distribution. So empirical rule, we can apply only bell shape, but Chebyshev's is for any distribution. It can be uniform or bell shape or skewed right or skewed left. All right? Okay, so let me just read for any data set or distribution, regardless of the shape, at least 75% of observation will lie within two standard deviation of the mean. So we found earlier, right? By empirical rule, we have a 95% within two standard deviation, right? And then Chebyshev said that that's 75%, at least, right? So it could be more, right? Yeah, because they said at least means that start to 75%, right? But then we found from the empirical rule, there is a 95%. Make sense to you? Okay. let's do this one. We learned how to use empirical rule. So let's find out these questions answer. Okay? Yeah. So table 14, average poverty, right? And then we want to know about 68%. And then we want to find the two values. 95%, we want to find the that values, right? Then what is the actual percent? Yeah, poverty rate or within two standard deviation. Yeah, okay, let's do it. Okay, so I brought the empirical rule, the picture, right? Okay, so one standard deviation means we have a 68%, so that's the A part, we can answer that, right? So what two values? Then within one standard deviation, so we want to find mu plus sigma and mu minus sigma, right? So we can use this information, right? So first part, we can calculate. So the first one, 68%, right? 68%. So there will be mu plus sigma. So mu, which is 12 point, how much we have to use? Maybe we use two decimal places because the original data set is one decimal place, right? So 12.03 plus sigma, that would be 2.93, right? Because we have a 2.927. Looking at the third one, 7 is greater than 5, round up. Round up means we give it to the 1 there, right? So that will be 2.93. Yes? All right. Now, can you please calculate? Okay, 14.96. How about subtract? So we can just using minus, what do we have? 9.1, yeah. So two values will be 9.1, 14.96. Yeah, let me write down. What did I say? Bad memory. Uh, let me fill it out. So what was the mu? Mu was 12.03. And that will be 9.1. Sorry, 14.96. That is 9.1. Yeah, that's the 68%. Two values. Make sense? Okay, now second part, 95%. So 95% will be here within two standard deviation, right? So we want to find out, calculate mu plus 2 times over sigma, mu minus 2 times over sigma. So that will be 95%. So mu plus 2 times over sigma. So 12.03 plus 2 times over sigma. What do you get? 6.17. How about mu minus 2 times over sigma? Using just subtraction. What do you get? Oh, sorry. This is a 6.17, yeah? Yeah, sorry. And then this one, 17.89. Very good. So two values will be 6.17, 17.89. Yeah. So here you go. So there will be 6.17. hold on 1 second, 6.17 and at 17.89, right? Okay, Third one, they ask us, what is actual percent that are within two standard deviation? So those values, right? Two standard deviation, 6.17 and 17.89. So let me write down. So two values will be two standard deviation between basically 6.17 and 17.89. Can you please count how many are there? So count. So seven. No, C. Actual, right? So C will be count between 6.17 and 17.89. How many are there? That's the percent, yeah. Because they talk about the poverty rate, right? Okay, so what do you get? Sorry, there is a two standard deviation, make sure of that, right? Yeah, 6.17 and 17.89. So there will be how many? 48? Oops. Out of yeah, n equal to 51 there, right? So yeah, here from the statements. So from the given, so 51. So what do you get? So it's a 0.9412. So we times 100%. Then 1, 2. So 94 or 4.12%, which is 94, 1.1. So what about the empirical rule? Empirical rule, we have a 95%. Actual percentage is 94.12%, right? Okay. Since in that case, we have only 51, the sample size, right? What if we have 1,000 sample size? How are you gonna count, right? Yeah. So it's better using empirical rule because empirical rule has 95% and the actual percentage is 94%, right? Make sense to you? Okay. Any other questions? Oh yeah, we done for this section. Woo. Okay, so I will see you in the next section. Thank you for watching. Bye.